A main breaker is a single unit, while a two-pole breaker consists of two separate breakers. This reduces the number of potential failure points and simplifies installation. Main breakers are generally more robust and reliable due to their single-unit construction. They are less prone to arc faults and other malfunctions. Main breakers have a compact design and can be installed in a smaller space compared to two-pole breakers. This is beneficial in electrical panels where space is limited. Main breakers have a single point of power interruption, making troubleshooting easier. If the main breaker trips, it indicates a fault in the entire electrical system. The 8 amperes interrupting capacity rating refers to the maximum current that a circuit breaker can safely interrupt. Generally, main breakers have a higher AIC rating than two-pole breakers. This means that main breakers are better equipped to safely handle high levels of fault current. Main breakers are generally more expensive than two-pole breakers. Main breakers may not always be readily available, especially in older buildings. In some cases, two-pole breakers can be configured in parallel to achieve the same current rating as a main breaker. While both main breakers and two-pole breakers serve the purpose of protecting electrical circuits, main breakers offer several advantages over two-pole breakers in terms of reliability, convenience, and space savings. They also have a higher AIC rating, making them better equipped to handle high levels of fault current. When choosing between a main breaker and a two-pole breaker, consider the specific requirements of your electrical system. If reliability and a high AIC rating are important, a main breaker is the better choice. However, if cost is a major concern, a two-pole breaker may be sufficient. It's always a good idea to consult with a qualified electrician to determine the best type of breaker for your needs. When dealing with electrical systems, it's always better to be safe than sorry. Understanding the capabilities and limitations of each type of breaker is essential for ensuring the safety and reliability of your electrical system. Consider factors such as the available space in your electrical panel and the potential for high fault currents when making your decision. If you're unsure which type of breaker is right for your situation, don't hesitate to seek professional advice. Electrical work can be dangerous, and it's always best to leave it to the experts. Remember that the AIC rating of a breaker is a crucial factor in determining its ability to safely interrupt fault currents. A breaker with a higher AIC rating can handle larger fault currents without failing, which can prevent serious damage to your electrical system and protect against electrical hazards. While cost is a consideration, it's important to prioritize safety and reliability when choosing a breaker. A higher quality breaker may cost more upfront, but it can save you money in the long run by preventing costly repairs and reducing the risk of electrical fires. Keep in mind that electrical codes and regulations vary depending on your location. It's important to ensure that any electrical work you do complies with local codes and regulations. This may require obtaining permits and inspections to ensure that the work is done safely and correctly. If you're not familiar with electrical codes and regulations, it's best to leave the work to a licensed electrician who is knowledgeable about these requirements. When working with electrical systems, always take precautions to protect yourself from electrical shock. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. Disconnect the power supply before working on any electrical components, and use a voltage tester to verify that the power is off. If you're not comfortable working with electricity, it's best to leave the work to a qualified electrician. Electricity can be dangerous, and it's important to take all necessary precautions to avoid injury. When replacing a breaker, be sure to choose a breaker with the same voltage and amperage rating as the original breaker. Using a breaker with the wrong rating can overload the circuit and create a fire hazard. If you're not sure what rating to use, consult with a qualified electrician. They can help you determine the correct breaker for your circuit and ensure that it is installed safely. Always follow the manufacturer's instructions when installing or replacing a breaker. The instructions will provide specific guidance on how to install the breaker correctly and safely. If you're not comfortable following the instructions, it's best to leave the work to a qualified electrician. They have the experience and knowledge to install the breaker correctly and ensure that it is functioning properly. Remember that electrical systems are complex and can be dangerous. It's important to approach any electrical work with caution and to take all necessary precautions to protect yourself from electrical shock. If you're not sure what you're doing, it's best to leave the work to a qualified electrician. They can help you with any electrical needs and ensure that your electrical system is safe and reliable. In summary, when deciding between a main breaker and a two-pole breaker, consider the following factors. Firstly, reliability and durability. Main breakers are generally more robust. Secondly, convenience and space savings. Main breakers are more compact. Thirdly, AIC rating. Main breakers typically have a higher AIC rating. And lastly, cost and availability. Two-pole breakers are generally less expensive and more readily available. Always consult with a qualified electrician to determine the best type of breaker for your specific application and to ensure that all electrical work is performed safely and in accordance with local codes and regulations. The amperes interrupting capacity (AIC) rating is a critical specification for circuit breakers. It indicates the maximum amount of fault current that the breaker can safely interrupt without failing. Fault current is the excessive electrical current that flows during a short circuit or ground fault. When a fault occurs, the current can rise rapidly to very high levels, potentially causing damage to equipment and posing a safety hazard. A circuit breaker with a sufficient AIC rating is designed to quickly and safely interrupt this fault current, protecting the electrical system from damage and preventing electrical fires. The AIC rating is typically expressed in thousands of amps, such as 10.0 amps, 22.0 amps, or 65.0 amps. The higher the AIC rating, the more fault current the breaker can safely handle. When selecting a circuit breaker, it is essential to choose one with an AIC rating that is equal to or greater than the available fault current at the point of installation. The available fault current can be determined through a fault current study, which is typically performed by a qualified electrical engineer. This study takes into account the characteristics of the electrical system, including the transformer size, conductor impedance, and other factors to calculate the maximum fault current that could occur at various points in the system. Using a circuit breaker with an inadequate AIC rating can have serious consequences. If the fault current exceeds the breaker's AIC rating, the breaker may fail to interrupt the current, leading to equipment damage, electrical fires, and potential injury or death. It is therefore crucial to carefully consider the AIC rating when selecting circuit breakers for any electrical application. In addition to the AIC rating, other important specifications for circuit breakers include the voltage rating, the amperage rating, and the type of trip mechanism. The voltage rating indicates the maximum voltage that the breaker can safely handle. The amperage rating indicates the maximum continuous current that the breaker can carry without tripping. The type of trip mechanism determines how the breaker responds to overcurrent conditions. Common types of trip mechanisms include thermal magnetic, electronic, and solid state. Thermal magnetic breakers use a combination of thermal and magnetic elements to detect overcurrents. Electronic breakers use electronic circuitry to detect overcurrents and provide more precise and adjustable tripping characteristics. Solid-state breakers use solid-state components to provide fast and reliable overcurrent protection. When selecting a circuit breaker, it is important to consider all of these specifications to ensure that the breaker is suitable for the intended application. Consulting with a qualified electrician or electrical engineer can help you choose the right circuit breakers for your needs and ensure that your electrical system is safe and reliable. In addition to understanding the specifications of circuit breakers, it is also important to follow proper installation and maintenance procedures. Circuit breakers should be installed by qualified electricians in accordance with all applicable codes and regulations. The breaker should be properly mounted and connected to the electrical system. Regular maintenance should be performed to ensure that the breakers are functioning properly. This may include visual inspections, testing, and cleaning. If a circuit breaker trips frequently, it may indicate a problem with the electrical system. The cause of the tripping should be investigated and corrected to prevent further problems. It is important to never reset a circuit breaker repeatedly without investigating the cause of the tripping. Doing so can damage the breaker and create a safety hazard. If you are not comfortable troubleshooting electrical problems, it is best to call a qualified electrician for assistance. They have the knowledge and experience to diagnose and repair electrical problems safely and effectively. When working with electrical systems, safety should always be the top priority. Following proper procedures and using the right equipment can help prevent accidents and injuries. If you are unsure about any aspect of electrical work, it is always best to seek professional advice. Electrical safety is not something to take lightly. By understanding the principles of electrical safety and following proper procedures, you can help protect yourself and others from electrical hazards. Remember to always turn off the power before working on any electrical equipment and to use appropriate personal protective equipment. With proper knowledge and precautions, you can work safely with electricity and enjoy the many benefits it provides. Furthermore, regarding the AIC rating, consider the specific application. For example, a residential electrical panel typically requires breakers with a lower AIC rating compared to an industrial facility with heavy machinery. The potential fault current in an industrial setting is generally much higher due to the larger transformers and electrical loads. Therefore, industrial circuit breakers need to have a higher AIC rating to handle these higher fault currents safely. In addition to the AIC rating, the interrupting time of a circuit breaker is also an important factor. The interrupting time is the amount of time it takes for the breaker to open and interrupt the fault current. A faster interrupting time can help minimize the damage caused by a fault and improve the overall safety of the electrical system. Circuit breakers with faster interrupting times are typically more expensive, but they can provide valuable protection in applications where minimizing fault damage is critical. Another consideration when selecting circuit breakers is the type of enclosure. Circuit breakers are available in a variety of enclosures, ranging from simple open-frame designs to sophisticated enclosed units that provide protection against environmental factors such as dust, moisture, and corrosion. The type of enclosure should be selected based on the environment in which the breaker will be installed. For example, in a damp or corrosive environment, a breaker with an M4 or 4X enclosure would be appropriate. These enclosures are designed to protect the breaker from water and other contaminants, ensuring reliable operation and extending the life of the breaker. When choosing a circuit breaker, it is also important to consider the manufacturer's reputation and the quality of the product. Reputable manufacturers typically offer breakers that are tested and certified to meet industry standards. These breakers are more likely to perform reliably and safely over their lifetime. It is also a good idea to read reviews and compare products from different manufacturers before making a purchase. This can help you identify breakers that have a proven track record of performance and reliability. Remember to always consult with a qualified electrician or electrical engineer when selecting and installing circuit breakers. They can help you assess your specific needs and choose the right breakers for your application. They can also ensure that the breakers are installed correctly and that the electrical system is safe and code compliant. Investing in quality circuit breakers and proper installation is a wise decision that can protect your electrical system, your property, and your safety. Do not cut corners when it comes to electrical safety. It is always better to spend a little more money upfront to ensure that your electrical system is protected by reliable and high-quality circuit breakers.